Hey folks, I'm super excited because at this point in the year, we are completely done learning new material for geometry. So what Miss Andre and I thought would be helpful to do with the last couple of the weeks of the year is to do some algebra review that will get you set up nicely for the algebra class that you're going to take in the fall. Now, because this is a review, I don't think that it's necessary for you to write notes or to take notes on this video. So maybe you just want to sit back and relax and watch, and we'll refresh your minds with some old concepts again that will be super helpful to you as you begin your Algebra 2 class come September. So the very first review that we came up with has to do with adding and subtracting polynomials. And hopefully if I use the phrase or the expression combine like terms, that's something that you've heard before, because really when we add and subtract polynomials, that's all we're doing is we're combining like terms. So I'm going to go ahead and just jump into example 1 here and we'll show you how it's done. Hopefully when you see this example, you're thinking to yourself, hey, I need to do some distributive property first. And if you are, your gut was in exactly the right place. So always the very first thing that I'm going to do when I'm faced with one of these problems is I'm going to distribute any terms that require distribution. So I'm going to multiply the 3 times the x squared to obtain the term 3x squared. And then I'm going to multiply the 3 times the minus 2 to obtain the term minus 6. And then I'm going to do exactly the same thing with the second set of parentheses. I'm going to distribute the 5x to the x to get 5x squared. And I'll distribute the 5x to the 3 to get 15x. And now that I've done the distribution, now I'm going to go ahead and combine like terms. And I notice that I have a 3x squared and I have a 5x squared. There are no other x squared terms in that expression, so I'm going to go ahead and combine the 3x squared and the 5x squared to get 8x squared. There are no terms with an x in it other than the 15x, so that'll stay a plus 15x. And there are no terms other than the negative 6 that are constants. In other words, they don't have an x squared or an x with them. Notice that I write this polynomial in standard form, meaning that the exponent with the highest value of 2 comes first, the exponent with the second highest value of 1 comes second, and that numeric term, that negative 6 or that constant, comes at the very end. And at this point, there are no more like terms to combine, so I know that I'm done. All right, notice that in example 2, what I'm trying to do is I'm trying to subtract one polynomial from the other. I know this because that operation in between the sets of parentheses there is subtraction. So in order to do this, I'm going to have to distribute that subtraction symbol to every term in the second polynomial. It's important to notice here, or pay attention to the fact that that first polynomial stays exactly the same. So it stays 5x squared plus 2x plus 8. But now again, I'm going to distribute that minus sign to each of the terms inside the second set of parentheses. So that becomes a minus 3x to the second, or minus 3x squared, a minus 5x, because a negative times a positive is a negative, and a plus 1 at the end, because a negative times a negative becomes a positive. And once I distribute the subtraction to every single term in the second set of parentheses, then I'm able to go ahead and do exactly what I did with the first example and just combine my like terms. So as far as the terms with the x squareds in them, I've got a 5x squared and a minus 3x squared, which will combine to be 2x squareds. As far as terms containing an x, I've got a 2x and a minus 5x, which will combine to be a minus 3x. And as far as constant terms, in other words, the terms that don't have an x attached to them at all, those will become a plus 9. And again, I write this in standard form with my highest exponent of 2 first, second highest exponent of 1 second, and that 9 that doesn't have an x attached to it at all comes at the very end. All right, number 3 is very similar to number 2, except for the way that they ask the question. They want us to subtract the polynomial 5x squared minus 3x plus 1 from the polynomial 8x squared plus 5x minus 1. So in other words, that first one is being subtracted, and it's being subtracted from the second one. I have to pay very close attention to the order here because the order in which I perform the subtraction will affect my answer. So again, it's the blue polynomial, the 8x squared plus 5x minus 1 that I'm subtracting from. So that becomes my first polynomial. And from that, I want to subtract the polynomial in green, or subtract the 5x squared minus 3x plus 1. And now that I've written my polynomial out, it becomes an example just like the one that we just did. So nothing changes about the first polynomial. That's going to remain 8x squared plus 5x subtract 1. But now I have to distribute that subtraction symbol. So it becomes a minus 5x squared. I have to distribute it to the minus 3, so a minus times a minus becomes a plus. And I have to distribute it to the positive 1. So a minus times a positive is a minus. And once I've distributed that negative symbol to all of the terms in the second set of parentheses, now I can go ahead and I can combine my like terms. So when I combine my x squared terms, I end up with 3 of them. When I combine my x terms, I end up with 8 of them. And when I combine my constants, minus 1 and minus 1, I end up with minus 2. Ooh, and when I look at this last one, it looks really scary, really tricky. It says, what is p of x minus q of x if p of x is equal to 5x squared minus 2x plus 1, and q of x is equal to negative 7x squared minus 10x plus 8. So again, what I'm looking for is p of x subtract q of x, but p of x is the polynomial 5x squared minus 2x plus 1. And from that, I want to subtract the polynomial q of x, which is negative 7x squared minus 10x plus 8. So again, I've got to distribute that minus symbol to the second set of parentheses. So I'm going to leave everybody in the first parentheses alone. But a minus times a minus is a positive. A minus times a minus again is a positive, so a plus 10x. And a minus times a positive is a minus. And now that I've done the distribution, I'm all set up to go ahead and do the combining my like terms. When I combine the terms with the x in them, I end up with 8 of them. And then lastly, the plus 1 and the minus 8 will combine to be minus 7. So there's a nice short little video for you on review with adding and subtracting polynomials. You've got some practice to do in Castle Learning. It's called Algebra Review Number 1, Adding and Subtracting. And I think if my memory serves me correctly, that there is a question in there that asks you to find the perimeter of a triangle. And I'm going to remind you that when you find perimeter of a triangle or of any polygon for that matter, you find it by adding the lengths of all the sides. So that might be helpful to you when you go do your CASA learning. All right, folks, I have to say I'm loving this algebra. It's been fun. In the next video, we're going to do some multiplication of polynomials. But for the meantime, have fun with that practice and the CASA learning. All right, take care, stay healthy, stay well, still missing you, and hang in there. We're almost there. Not too much longer to go now, folks.